In this video, I'm going to show you how to create a parametric baffle ceiling or a waffle ceiling in a different shapes that you can use it as a triangle, circle, rectangle, and hexagonal. So we will use a Rhino inside Revit, which means that we are working on a Grasshopper script that will show the result at the end inside the Revit. Of course, you don't have to follow the Revit file. You can use just a Rhino and a Grasshopper files. So let's get started. Okay, so this is the Revit file that we are working on it, and in this case we have a small room that we will work on the script. So make sure that you have modeled the surface, the ceiling, which is in our case, and make sure it has been modeled so you can pick it up to the Grasshopper. So first, here there is a Rhino inside Revit. Go to there, open the Rhino, then Grasshopper. Then let's search for face. Face, you can find it here in the parametric and in the Revit. These groups, you have two groups for Revit elements for in Grasshopper, so you can contribute and give in and out from Revit to Rhino. So in this case, just right click, set one face, go to your surface. In this case, our surface is the ceiling, so we need to pick the bottom point. Then you have to see it in Rhino. Yeah, that's it. Okay. And actually, if you edit this surface, or it's okay, we can keep it at the end. This one, I will show you something at the end. So from this command, search for command Voronoi. And also we need to have the populate 2D. Populate 2D is the command that helps you to generate a point inside the surface. So let's say you have a surface, and inside the surface multiple point will be generated randomized, depend on the surface border and depends on the count that you can decide it later. So in this case there is a red warning, which is cannot actually define the surface automatically from Revit. So you have to convert it at least to Rhino surface. Then from Rhino surface, going to region. You can hide this. So as you see, there is a point. Add a slider to control the counts, to control the count of the point. See on the right, is generating the point. So let's stay with 50. I think 50 is enough. Okay, from the population, which is the generated points, we add it to the Voronoi cell. Then to control the Voronoi to touch and attach to the exact boundary of the surface, connect to the boundary. So the second thing that we need to move each cell to the downside. So just to this, yeah. Okay, sorry for that. Okay, next step, we need to move each cell to the downside, to the Z direction and minus. To do that, let's search for the command move and add the cells to the geometry, and the motion will be a unit Z. Unit Z means the vector Z, that direction, which direction you want to move the elements. So it's moved, but you cannot see because it's a very, very little amount, a very small amount that you cannot see. So to control this, we need to add a slider in 50, if you added 50, it will be in the upper side, in the above. And if you wanted to the okay, I don't know what's happening here. Okay, you need the same amount but with minus direction. See, it's reflected to the down, and if you increase it in minus, the cells will move down more. So I can see that we need to increase the amount. As you can see, the the pattern, it's moving down more and more, which is makes sense. I believe if we can see it in the Revit. Okay, I think yeah. Here you can see the progress, what's happening in Rhino. It reflected and synchronizing in in a leveling inside the Revit. Okay, I to add a dramatic movement with the cells, we need to change or add a multiple direction to each cells, so you can have a randomized uh, kinetic movement for the cells. In one command, which names series, at the start, we will go with the minus. Okay, and from here, add it to the factor. I think 500 is enough. And the steps, let's say between each cell, like 6 steps, for example. Okay, you can see, but for more better result, we need to get the count, which is how many count you want the randomized amount will be. So the make sense here, it's we need the amount of how many cells we have. How many cells we have? It's easy. It's 50 points, mean 50 cells. To get the number of the cells, don't just go to the don't connect immediately and directly from here or here. You need to have this comment. This is very important comment. Add it here and the length, and you can see here is okay. Now you can see clearly. Let's hide this, the previous, that we don't need it. Okay, and I think it works perfectly. Now you can adjust this as per your own desired, but I think we can go with the minus 500, and 6 is enough. Okay, the last part that we need to convert this curves, Voronoi curves, it's not a 3D model. So let's convert it to the 3D first to the 2D surface, and to make it so we can add a thickness and a 3D shape. I'm, I prefer always to use this command, as I showed you before in the previous videos. This surface, offset surface, in pufferfish, add geometry to the surface and add some thickness. Distance is the thickness. I'm going to use 10. Okay, I think we can go more higher. Okay, be careful to not clash with any other surface. Okay, just to add a small touch, you can fill it. edit the surface. Yeah, okay. Yeah, I think this is much better. So here in Revit, you can see the result. And if you want to add to work more, you can just work it as a MEP, add in the lights, the MEP ducts, and anything that you want to add above the ceiling. Okay, the final step, how you can send this object to the Revit in simple uh, command, add direct shape. Direct shape happening here. Direct brep. Yeah. Okay. Now you can close the Revit, the Rhino, sorry, and the Grasshopper, and you can see that the buffles or the pattern has been baked into Revit. Okay, that's for today. See you next one.